Hello and welcome to this new tutorial. Now we're going to tackle the consensus problem by creating this replace chain method that will replace any chain that is shorter than the longest chain among all the nodes of the network. So actually we already started in some way the decentralization of our blockchain, but the real decentralization will happen in part 3 when we'll make that request to not only add some new nodes, connect them to each other, and then of course apply the consensus whenever a new block is mined in any node. So that's what I mean by the real decentralization. But indeed, since we already created that set of nodes in the previous tutorial and made that add node method, well, we actually started the decentralization. But now we're going to tackle the consensus, and that's why I prepared some space here for a new method which we'll call replace chain. And this replace chain function is going to take only one argument, which is self. And why is that? That's for an important reason. It's because we will call this function in a specific node. And since each node contains a specific version of the blockchain, whether it is up to date or not, well, we will need to apply this replace chain function inside a specific node. So let's do this. Let's implement this replace chain function. And to do so, what we need to start with is to introduce a new variable that we're going to call network. And that will be, of course, our network containing all the nodes. And therefore, this network will be nothing else than our set of nodes, self.nodes. So we can visualize this. This network variable is our set of nodes all around the world. All right, so that's our network. And now, since this replace chain function is supposed to replace the chain inside the node on which it will be applied by the longest chain, well, naturally we need to introduce a longest chain variable which will be, at some point in this implementation of this replace chain function, the longest chain. So we'll introduce this new variable, longest chain. However, right now we have no idea of what is the longest chain because we haven't basically scanned the network yet, and therefore we will just initialize it so far as none. But then you'll see at some point we will do a for loop to loop over all the nodes in our decentralized network. We will find the node that has the longest chain, and once we find that node, this variable longest chain right here will become the chain of this node. All right? So, speaking of the for loop, just before we start this for loop, we need to introduce another variable which will be very useful for us to find the longest chain. Because in order to find that longest chain, we will simply compare the length of the chains of all the nodes in the network. And therefore, based on the same idea of introducing this longest chain variable, which will become the largest chain at some point, well, we will introduce the max length variable, which will be, of course, the length of the largest chain. All right? But we're not going to initialize this as 0 as we did initializing the longest chain as none. We are going to initialize this max length variable as the length of the chain we are dealing with right now. That is, the chain of the blockchain inside the node on which we are applying this replace chain method. All right, so that's the max length so far. And if we find a chain that has a length larger than this one, the max length, which is the length of our chain right now, well, of course, we will update this max length variable, and accordingly, we will update the longest chain. Perfect. And now we're ready to start the loop. So, is it going to be a while loop, a for loop? Well, in that case, since we want to iterate on the nodes of the network, a for loop seems to be the best choice. So, we're going to do a for loop because naturally, we're going to loop over the nodes in our network. The nodes in our network, and for all the nodes in our network, what exactly are we going to do in that for loop? Well, first, what do we want to do? We want to find the largest chain, that is the chain that has the largest length. How can we find this chain? Very easily, based on what we built before, using the tools we already implemented. Well, if you remember, in module 1, create a blockchain, we made that getChain request that returns not only the chain, the whole chain of the blockchain, but also the length. It returns the length. So what we could do now is get the length of our chain, because this replace chain method is applied on a specific chain in a specific node. So what we could do is send a request of getting the chain inside this node we're applying the replace chain method, and therefore get the length of this chain. And so we'll do that for all the nodes in the network, and therefore we'll get basically the length of all the chains, and that way we'll be able to find the largest length, the length of the largest chain. So let's do this. That was the trick, to do that efficiently, to use the request. And to use the request now, that's exactly when we're going to use this requests library that we not only installed in the terminal or Anaconda prompt at the beginning of this module, but also that we imported here. So we're going to use that requests library to get exactly the response, that is this response right here, of the get chain request. So that means that we're going to get exactly this data. We're going to get the chain and the length of the blockchain inside this node we're dealing with inside this for loop iterating on all the nodes in the network. So that's the trick. Let's do this. Let's introduce, well, a new variable here, which will be response, because this is exactly what this requests library is going to give us. And by the way, we will not directly use the request library, but of course a function, the get function from this request library, which will give us that response. And speaking of this get function, that's exactly what we're going to get right now. So first, let's get our requests library. And from this request library, let's get the get function to, well, exactly get the response of the get chain request. So now there's another tricky thing to do. How exactly are we going to call or send this get chain request? This is the get chain function that is based on this real get chain request attached to the get method. How are we going to send that request exactly? Well, to answer this question, we must understand what this get function by the request library is supposed to receive as argument. Well, what it is supposed to receive exactly is the whole address of the node, including the port, plus, of course, the request. So I'm going to show you exactly what it is expecting. We've already done that in Postman, and so that you understand this the best way, what it is expecting exactly is not only this address, which is the address of the node because it is including the port, but, remember, that's the address. And then remember, we need to add the request get chain. And this is exactly what is expecting the get function we're using from the request library to get the response. So I'm copying this. This is exactly what we're expecting. And now let's go back to Python and let's go back to our replace chain function and in quotes paste this. But this is not all. We have one final little trick to do. It is of course related to the fact that we are looping over the nodes of the network, and the nodes are differentiated by their port. They have this common URL 127.0.0.1, but then they're differentiated by their port. So this port 5000 here is just a port for one node, but then the other nodes will have ports 5001, 5002, 5003, as many 5000s as the number of nodes. And so here 5000 was just an example, and of course we need to get the port of the node we're dealing with right now at the specific time of the loop. And to get this node, well, we will need to replace this URL including the port by something specific, which is, it's actually very simple, that's the node. The node in our set of nodes. Because remember, in the previous tutorial we made this add node function, which added exactly in our set of nodes the URL of the node including the port, and therefore, if we take this example again, well, what a node in the network is exactly equal to is this parsed URL network. So I'm going to write this. Any node in the network is equal to this parsed url.netlock that we added right here at the end of this add node method. That's what each node is exactly in our set of nodes. So I'm going to press enter here, and just to show you this is exactly how the nodes are identified in the set of nodes. And therefore, what we need to replace exactly in order to be consistent with the nodes in our network is simply, well, the nodes. And we are iterating on the nodes in the network, but we're doing this for each node separately. So for each node in the network, well, we'll get the response of the following request. And to generalize this to any node in the loop, well, since the node is exactly equal to this, we'll replace this URL, including the port, by the node. And there we go, we are almost there. But now we just need to make this node in some brackets, because we're going to use the f-string function thanks to this beautiful Python 3.6 syntax that we have, because we are on Python 3.6. And this f-string syntax is just to add here f, and that's it. I can now show you the magic. If I take this, copy it, and paste that here in the console, well, remember node is equal to this, and therefore when I press enter, we get exactly the request of getting the chain, the whole chain in the node of port 5000. So we win, we have exactly what we want, that is the response which will get us the length of the chain. And that's exactly our next step. Now we're going to get the length of this node, but we're just going to do a quick check to check if everything's okay. Remember, this getChainRequest not only returns the response in the JSON format, but also the HTTP status code 200 to confirm that everything's okay. But we need to do a quick check here to check indeed that everything's okay. And to check this, we'll take, well, our response, get the status code attribute of this response, and we're going to check that the status code is well equal to 200. And if that's the case, well, we can take the length. And that's exactly what we're going to do now, taking the length. And to take the length, well, again, we take our response, and then we're going to use the JSON function, because, the response is given in the JSON format. And therefore, basically, to get this length, we're going to use the JSON function to catch in square brackets the key of the length, because the JSON format is exactly the dictionary format with keys and values. So basically we're like taking the length key of a dictionary, which will get us the length of the chain. So basically that's how you get the length of the chain. And since this returns something, which is the length, well, we'll introduce here a new variable which we'll call the length, and that corresponds of course to the length of the chain. All right, almost there. We have the length, which is good because we'll be able to check if it is the largest length. But remember that we also want to replace the chain if indeed this length is not the largest one. And therefore we'll also get the chain from our response, which we get also thanks to the JSON function here, but then a different key, same in brackets, which is of course the chain key, because this getChainRequest returns the length and the chain. So here we have the length, we have the chain, that's perfect. And now let's do the check if the length of the chain we just got here in the response is larger than the largest length, which is in our max length variable. But then we're also going to check, and that's where our isChainValid method comes into play. We're going to check that the chain we just got in the response, that is the chain in our node, is valid. We need to check this, otherwise this chain doesn't even have a reason to exist. So we're going to check this, and therefore we're going to call that method. And since it is a method of our class, we need to add here self dot and then isChainValid method, taking as argument, of course, the chain. And so if the length that we just got here in the response is larger than the max length, that is, the length of the largest chain, and if the chain we're dealing with right now in this specific node in the for loop is valid, well, in that case, what we need to do is update our max length variable, because basically we found a length that is larger than the max length, so we need to update that max length to be this found new length. So max length will become length, and of course, well, the longest chain, which was so far initialized to none, will need to be updated as well as the chain of the response that indeed has a length larger than the maximum length. So basically it's the largest chain found in the loop over our nodes. Okay, so we need to update our longest chain as well, which becomes this chain we are dealing with right now in this specific node. Okay, so perfect. Now the next step is, well, first get out of this if, and then we simply need to add another if condition here. And now we're going to use a beautiful trick in Python, if longest chain colon. Why is that? Well, basically that means if longest chain is not none, because if longest chain is not none, that means that longest chain was updated because it was initialized to none, and therefore that means that a replacement was made, and therefore that means that the chain was replaced. So that's a nice little trick, and therefore if longest chain is not none, that is if the chain was replaced, well, in that case we're going to return true, just to specify that the chain was replaced. We're going to return true, and of course what we're also going to do is indeed replace the chain, because we actually haven't done it yet. We have replaced the longest chain variable, but our chain in our blockchain self here was not replaced yet effectively. And therefore, that's exactly what we need to do now. We need to take our blockchain with self. You know, self will become the object once we get out of our class. So self.chain, the chain of our blockchain, in our node inside which we're sending the request, and self.chain becomes, well, the longest chain that was correctly updated right here in the loop. Self.chain equals longest chain, return true, and then on the other hand, if longest chain is none, that is, if this original value of none with which it was initialized was not updated anywhere in the for loop, well, in that case, that means that no replacement was made, and therefore our chain was originally the largest one, and so we simply need to return here false, as in the chain was not replaced. Alright, and that's it. That's our replace chain function. We're going to use this function, of course, in a new request we'll make in part 3, decentralizing our blockchain, because that's where we'll interact with all the nodes and apply the required actions to have a proper decentralized network. So we'll use this in part 3. And now I just want to say congratulations, because we are done with the development, that is the required development of part 1 to turn this blockchain into a cryptocurrency. So now we'll move on to part 2, mining our blockchain. We have some updates to make. You know, for example, in mine block here, we need to consider the transactions, of course, because the transactions in our list are added to the next block that is mined. And so we'll implement that here, and then we'll add some other requests. We'll do that in the next tutorials, and until then, enjoy blockchains.